All right, folks, it's back in action here. In this video, we are going to go through two different things. On the inside of your foldable, we're going to be on the inside on the left side, and we're going to be looking at that bottom. So that you need to open it up and look at that inside left on the bottom. We're going to look at how to find measures of arcs when the vertex is on the center, and then we're also going to apply this idea and find arc length by looking at the back of our foldable. So we're going to start here on that inside on the bottom left. So vertex is on the center. When we did our vocabulary, we've already talked about a central angle. So vertex on the center is going to create a central angle. So for example, you can see right here this angle EKY would be a central angle because its vertex is on the center. The sides of the angle contain radii of the circle. You can also notice over here I've got some notation. We've seen this arc notation already, but you'll notice that now I've got this M in front of all of my arcs. That M is going to stand for the word measure, and measure is going to be a very important distinction from what we're going to do on the back of this foldable at the end of this video. So the measure of an arc, if the vertex is on the center of the circle, is going to equal the measure of the central angle. So the measure of this arc, for example, is going to equal the measure of the angle. This arc here, this portion of the circle that's inside this angle, is called an intercepted arc. So this intercepted arc will match the angle. So we can write a very, very simple formula here, and we're going to say measure of an angle, and we're going to say equals the measure, and these M's are important, is going to equal the measure of the arc. So what I generally suggest students do is fill in as many degrees as you can, either right here in the center of the circle or around the arc, whichever one happens to make the most sense for that problem. So for example, if this is 47, we can see that this is a diameter. We could fill in this angle right here as 133. We're just going to fill that in right away. We can fill in this other side of 180 because this is clearly a semicircle. So if we want to find the measures of these arcs, our answer is going to be in degrees. So the measure of arc EO, remember 2 letters tells us it's going to either be a semicircle or less than 180. So we're going to start at E and we're going to go to O. There we go. Those EO is the endpoints of that diameter, so this one is going to be 180. Now, if we want this OY, remember we have a choice. Should we go from O to Y, or should we go O to Y this way? Well, 2 letters tells us it should be less than 180, so we're going to go the short direction, and the measure of this arc is going to match the angle, that central angle, so it would be 133. The measure of YEO, so now we've got 3 letters. So now we're going to be looking for a measure that's going to be more than 180. So we're going to say Y to E to O. So we can either add these 2 together, this 47 plus this 180, or you could think, hey, I've got the whole circle here, and you could subtract 133. Either of those are going to get you to the measure of that arc of 227. Now we're going to look at this other picture over here, and this one's really important. Remember, these are called concentric circles. And what I want you to recognize and think about is that the length of this circle, this inner circle here, is clearly smaller than the length of the outer circle of those central angles. But when we're talking about measures of arcs, the measures are purely going to be based on these central angles. So let's mark the information that we're given here. We've got an angle EDG of 150 degrees. So we're going to find that in our picture here. So EDG, we're going to put our 150 right there. We're also going to be told that these 2 arc measures are the same. So BE and BG. So let's find those. Here's BE and here's BG. Well, these 2 arcs are supposed to be the same. Well, if the arcs are the same, then their central angles should also be the same. So we can mark those as congruent as well. Now, we all understand that all these angles, there's 360 degrees in a circle. So if this angle right here is 150, we can go ahead and just take our 360, subtract our 150, and we'll get our 210, and then divide that 210 into the two individual pieces right there, and we can fill in then the 105 and a 105. From there, we can now go back and we can find these answers. E.g., two letters should be less than 180, so when we're deciding, should I go E to G or E to G, only this direction is going to give us something smaller than 180, so we'll fill in our 150. If we want our AK, again, two letters, less than 180, we've got our two choices, this direction or this direction. You have to choose the one that's less than 180, and the measure of this arc will match its central angle, so it will be 105. Our last one that we're going to do here is going to be ACK. We've got three letters, so we know we want more than 180, so we're going to go from A to C to K. We're going to add these two together, so this 105 and the 150, or you could think the whole circle and just subtract off that portion. Either way, you're going to get 225 degrees. Okay, so now that we've taken a look at central angles, we're going to flip to the back of this foldable, and we're going to look at just a small example from the back of the foldable. We're going to look at just this one example here about arc length. So we're going to do a comparison of arc measure versus arc length. So arc length is actually going to talk about how long the circle is. So let's take a look at our definition. The length of an arc is going to be equal to a portion of the circle. So our definition says that length equals a portion. Now the portion of the circle is going to be a fraction, so it's going to be the arc measure, that's what we just did, divided by 360 degrees. So this is going to give us how much of the circle we want, what portion or fraction we want, and then we're going to multiply that by the circumference of the circle. Now, you can rearrange this formula into a nice proportion, and some students are going to prefer this method. It's not going to matter which method you choose. Everyone's going to have their own preference. If we rearrange our formula algebraically, what we will get is arc measure divided by 360, and that will equal arc length divided by the circumference. Now, we should remind ourselves that the formula for circumference is 2 pi r, or pi times diameter, whichever one you want. So let's take a look here at an example. We're just going to do just this one example right here. The first thing that I want you to notice is that on parts A and B, I've got these m's. This tells us that our answer is going to be in degrees. So back to what we just did in the earlier part of the video, I have a 50 degrees here. I know all the degrees in the circle should add up to 360, so I can fill in this other portion right here of 310 degrees. So the measure of arc GH in degrees then, G to H is the short way, it'll be 50 degrees. Then HUG, now we've got three letters, more than 180, we're gonna go all the way around. That's going to be 310 degrees. So if we want to find the length of HUG, and the way you're going to tell the difference between these two problems is that the measure questions for degrees will have an M, and the length questions will not have that M. So if you don't see the M, you know that you're going to have to do this longer process. So we're going to have two choices. The first one that we could do is we could look at our definition, and we could say that HUG, that arc, put your symbol over the top, we're going to look at our portion, 310 out of 360, because this arc has this as its angle, and then we're going to multiply that by the circumference of our circle. So the circumference of our circle, we're going to find that radius of 9, and we're going to fill in our 18 pi. Now, if we go through this algebraically, this 18, actually I'm going to reduce these zeros first, and then the 18 will divide into the 36 twice. Nothing else is going to reduce, so I still have a 31, I still have a pi, I still have a 2. So the length of this arc is going to be 31 pi over 2. And we'll put a little u on there for units. Now, our other option would be that proportion method, and what you would do is you would say 310 over 360. Either way, you're going to take that portion, and now we're going to say, hey, I want to know the length, but I do know the circumference, and that's going to be 18 pi. And now you're just going to solve your proportion the same way that we did back in Chapter 7 or in your Algebra 1 days. You can reduce that side. We can cross multiply. So 36x, and I'm going to leave this, I'm not going to multiply this out. It's going to be easier if you leave it that way. I'm going to divide both sides by 36. Cancel, cancel. This will cancel. And I just realized I didn't write that 1. Let's fix that. Make sure that you've got a 31 here and not just a 3. And sure enough, we get the exact same answer here for the arc length of 31 pi over 2. So same answer no matter which method that you do.